November 22nd, 1944, near Lohn, Germany. Oberleutnant Werner Schultz crouched behind the stone foundation of a collapsed barn, his binoculars fixed on the American column advancing through morning fog. 3 Shermans, maybe 4. Standard procedure. Hit them from 800 yards out. The 88mm Pak 43 sat ready, its crew veterans who'd killed 17 American tanks since Normandy. Target left, Schultz whispered into the field telephone. Hull down position, 800 meters. The first Sherman rolled into view. Something looked wrong. The silhouette was standard M4, but the front looked thicker, the turret more massive. Schultz adjusted his binoculars. The glacis plate appeared steeper, the armor casting deeper shadows than a normal Sherman. He'd seen hundreds of these tanks burn. This one looked different. Fire when ready. The Pak 43 cracked. The first round struck the glacis plate dead center at 30 degrees obliquity. Schultz waited for the familiar sight, hull penetration, smoke, crew bailing. Instead, the shell ricocheted skyward with a metallic shriek that echoed across the frozen field. The Sherman kept moving. Again, center mass. Second shot, direct hit on the turret front. The round bounced off the gun mantlet without penetrating. The Sherman's turret began traversing, slowly, deliberately, toward their position. Hit the mantlet again, Schultz ordered. Nothing gets through that armor. Physics doesn't lie. Third shot struck the same target point. Another ricochet. The Sherman was at 700 yards now, still advancing. Schultz felt ice in his stomach that had nothing to do with the weather. This wasn't supposed to happen. German 88mm guns didn't fail. American Shermans didn't survive 3 direct hits. The mathematics of armor penetration didn't suddenly stop working. The fourth shot, aimed at the gunner's periscope opening, Nacho found its mark. Penetration. Finally. But the tank was still operational, and Schultz's crew had just given away their position to whatever monster was inside that Sherman hull. That morning, German anti-tank crews discovered something Allied intelligence had kept quiet for 4 months. The Americans had built a Sherman that German weapons couldn't kill, and sitting in armoured workshops across France, American ordnance officers were preparing to make that invincible tank even deadlier. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. May 6th, 1944. Fisher Body Tank Arsenal, Grand Blanc, Michigan. The first M4A3E2 rolled off the assembly line at 0645. Workers called it Jumbo before the designation was even official. 42 tons, compared to the standard Sherman's 30 tons. An extra 12,000 pounds of steel, welded, bolted and cast onto the M4A3 frame. Colonel James. Taylor stood in the factory bay, watching as Union Steel's massive differential housing was mated to the hull. 5.5 inches of cast armor at maximum thickness. He'd spent 4 months fighting the procurement bureaucracy to approve this project. Now he was watching American industrial capacity do what it did best, turn theory into reality at speed. "We're behind schedule," said Captain Richard Morrison, the project's engineering liaison. "Contract calls for 254 units by July. We've completed 6. Taylor knew the numbers. The War Department wanted these tanks in France by D-Day. That deadline had already passed. The next deadline was August. Getting 248 more M4, a 3E2S built in 3 months, meant Fisher Body had to maintain production rates that would have been impossible 2 years ago. "How's the armor testing?" "Aberdeen ran ballistics yesterday." Morrison pulled a folder from under his arm. "The glacis plate tests at 100, 49mm effective thickness at vertical impact angles. Side armor, 76mm. Turret front, 152mm all around." Taylor did the mental calculation. A standard Sherman had 63mm on the glacis. The Jumbo had more than double that protection. The turret armor exceeded what the German Tiger I carried. What about the suspension? That's the problem. Morrison's expression tightened. Vertical volute spring suspension wasn't designed for 42 tons. Front bogies are taking tremendous strain. We've already seen spring failures in durability testing. The suspension works, but crews need to know it's operating at the limit. They walked to where a completed jumbo sat next to a standard M4A3 for comparison. The differences were obvious. The jumbo sat lower, its suspension compressed under the weight. Extended end connectors, duckbills, widened the tracks from 16 inches to 21 inches to distribute ground pressure. The final drive had been strengthened and geared down, reducing top speed from 30 miles per hour to 22. "It's a pillbox on tracks," Taylor said, "not a racing tank." Morrison handed him a document marked restricted. Ordnance wants them armed with the 75mm M3. The thought is these will be assault tanks supporting infantry. High explosive firepower matters more than armor penetration. Taylor looked at the turret mounting. The M62 gun mount had been designed for the 76mm M1. Fitting a 75 into that mount required an adapter, but it meant swapping guns later would be straightforward. Field modification if doctrine changed. What's production looking like now? We're averaging 4 units per day. We'll hit the 254 by late July if nothing breaks down. These tanks are already spoken for. 4th Armoured Division gets priority allocation. Patton's been requesting heavy assault tanks since. Tunisia. The first M4A3E2 completed acceptance trials on June 8th. By June 28, 23, jumbos had cleared final inspection. The first shipment left for Europe on July 2nd via Liberty ship convoy. Transit time, 22 days across the Atlantic, then overland movement to forward supply depots. Timeline put the first jumbos in France by early August at the earliest. Taylor knew what was happening in Normandy. American tank losses were catastrophic. Sherman crews were dying by the dozens facing Panthers and 88mm guns in hedgerow country, where tactical maneuver was impossible. Every Sherman commander in France would want a jumbo. Every infantry assault could use one of these tanks at the front of the column. But there were only going to be 254 M4A3E2s. Ever. One production run, that was it. The Army had placed orders for the M26 Pershing, and Ordnance believed that heavier tank would replace the need for up-armoured Shermans. The jumbo was a stopgap, a temporary solution to an immediate problem. What nobody knew yet was whether 254 tanks would be enough, or whether American crews would figure out how to use them before German anti-tank gunners figured out how to kill them. September 22, 1944, Arlon, Belgium. The flatbed trucks arrived in the assembly area, carrying something Sergeant Frank Rousseau hadn't seen before, Shermans that looked like they'd been built inside a steel vault. 7 M4A3E2s for the 743rd Tank Battalion, part of the First Army's commitment to urban assault operations. Rousseau walked around the first tank slowly. The glacis plate caught the late afternoon sun, showing weld beads where additional armour had been applied. The turret looked wrong, too thick, too heavy. The gun mantlet was enormous, 180mm of cast and welded steel that covered 3/4 of the turret front. "That's a jumbo," said Lieutenant William Holbrook, the battalion's new tank platoon commander. 254 built. We got 7. Consider yourself lucky. Lucky how? Holbrook climbed onto the hull, pointing out features. Frontal glacis is 4 inches thick, base armour, sloped at 47 degrees. That makes it about 6 inches effective thickness. German 88s can't penetrate at combat range. The turret is based on the T-23 design, 6 inches all around. Even the sides and rear are thicker than a standard Sherman. Rousseau had commanded a Sherman since Normandy. He'd lost 2 tanks to German 88s, watched 3 more brew up from Panzerfaust hits. The idea of armour that could stop those weapons seemed like fantasy. What's the cost? 12 tons heavier, top speed 22 miles per hour, same suspension as the regular Sherman, so don't hit bumps hard or you'll crack the front springs. Fuel capacity is the same, but you're pushing more weight, so range is shorter. Holbrook tapped the 75mm gun. Main armament is the same short gun. This isn't a tank killer. This is infantry support. You lead the column, you take the hits, you suppress enemy positions. The crew assignments came down that afternoon. Russo got Jumbo number 4. His gunner, Corporal James Patterson, climbed into the turret and immediately started complaining. This thing's cramped. Turret basket's tight. Gun mantlet blocks half the forward view. Gun mantlet blocks German shells, Russo said. I'll take tight quarters over getting brewed up. They ran familiarization exercises for 2 days. The Jumbo handled like an overloaded truck, sluggish acceleration, wider turning radius, constant awareness of ground conditions. But when Russo positioned the tank hull down and watched a captured German PaK-40 fire test rounds at a junked Jumbo hull, watching the shells bounce off armor that didn't fail, he started believing what Holbrook had promised. This tank could survive hits that would kill a standard Sherman. The tactical doctrine was simple. Jumbos led every advance. They took point on road marches. They spearheaded urban assaults. Their job wasn't to kill enemy tanks. It was to survive long enough for lighter, more maneuverable Shermans to flank and kill. The Jumbo was a bulletproof shield on tracks. What nobody told Russo's battalion was how German anti-tank crews would react when they discovered the 88s no longer worked, or how American ordnance officers were already planning to solve the Jumbo's one critical weakness, its inability to fight back against heavy German armor. October 14th, 1944. Aachen, Germany. The urban combat was exactly the nightmare everyone had predicted. German defenders turned every building into a fortress. Panzerfaust teams operated from basements and third-floor windows. American infantry couldn't advance without armor support, and armor couldn't operate without infantry. Screening. Staff Sergeant Robert Early's Jumbo took point on every street. The morning of October 14th, his tank led a column pushing toward the city center. The visibility was maybe 200 yards in the rubble-choked streets. Early kept the tank in second gear, watching rooftops and basement windows. The Panzerfaust hit at 80 yards, striking the right side of the turret. The hollow charge warhead detonated on contact. Inside the turret, the explosion sounded like someone hitting the hull with a sledgehammer. Early's ears rang. His vision blurred from the concussion. When his head cleared, he looked for penetration. Nothing. The shaped charge had burned through the external armor, but failed to penetrate the thick turret casting. Early's crew was alive. The tank was operational. The German who'd fired the Panzerfaust was probably reloading right now. Traverse right, third-floor window, high explosive, fire. The 75mm M3 gun spoke. The high, explosive round detonated inside the building, collapsing the floor. 2 more Panzerfaust hits struck the glacis plate during the next 4 blocks. Neither penetrated. By the end of the day, Early's Jumbo had absorbed 17 anti-tank weapon impacts. It rolled back to the maintenance area under its own power, with surface scarring and no combat losses. Other battalion commanders started requesting Jumbos. The demand exceeded supply by a factor of 20 to 1. Only 254 existed in the entire European theatre. Units that had them protected them jealously. Units that didn't have them improvised, welding spare armor plates onto standard Shermans, adding sandbags, bolting track sections to the glacis. General George Patton saw a Jumbo demonstration in late October and immediately requisitioned every available M4, A3, E2 for Third Army. When Ordnance explained that no more were being built, Patton issued an order that became legend in American tank maintenance: strip the armor off any non-functional Sherman with a welded hull and use it to up-armor the tanks we have. Third Army maintenance battalions started field-expedient armor programs that violated every engineering specification but kept Patton's armor moving. The official Jumbos became precious commodities, assigned to spearhead units where their survival mattered most. And then someone in Ordnance asked the question that would change everything: What if we gave the jumbo a gun that could actually kill German heavy tanks? The M4A3E2 had been designed as an infantry support vehicle. It carried thick armor and a weapon optimized for high explosive performance. But by November 1944, the tactical reality had shifted. Jumbos weren't just supporting infantry anymore. They were leading armor columns, engaging German tanks, fighting in roles their designers never intended. The 76mm M1 gun existed. It had been mounted on standard Shermans since July. The M62 gun mount that every jumbo carried had been designed for that exact weapon. Swapping guns was mechanically straightforward. The question was whether anyone would actually do it, and whether American tank crews would figure out what the 76mm gun could really do before the winter fighting consumed them all. December 15th, 1944, Mechelen, Belgium. The maintenance depot occupied a former Belgian army garrison. Captain Harold Richmond commanded the 46th Ordnance Battalion's tank maintenance company. His mission was simple: keep Third Army's armor operational. But the order that came down from division that morning was anything but simple. Convert available M4A3E2 jumbo Shermans to 76mm armament. Priority 1. Timeline: 7 days. Richmond read the order twice. Converting tank armament wasn't unusual, but doing it to the jumbo, to a tank that officially didn't exist in replacement stocks, 22, meant this was coming from high up. He pulled the technical manuals and started calculating what the job required. The mechanical work was straightforward. Remove the 75mm M3 gun and mount. Install the 76mm M1 gun in the existing M62 mount. The mount had been designed for the 76mm originally, so the installation was plug and play. The difficult part was ammunition stowage. The 75mm shells were shorter than 76mm rounds. The ammunition racks needed modification, longer slots, different securing brackets, complete turret removal to access the floor stowage. Technical documentation said the conversion required 75 man-hours per tank. Richmond had 3 jumbos in the maintenance bay, knockouts from the autumn fighting, repaired and awaiting return to service. He put his best crews on the conversion, working 12-hour shifts. The first gun swap took 80 hours, the second took 63. By the third tank, the crews were averaging 70 hours, just like the manual predicted. The 76mm guns came from knocked-out standard Shermans. Ordnance doctrine said salvage every weapon possible. Battlefield recovery teams pulled guns from burned-out hulls, inspected them for damage, and shipped them to maintenance depots for reinstallation. The guns going into Richmond's jumbos had already seen combat. They'd killed German tanks before. Now they were getting a second life in a platform that could actually survive long enough to use them properly. On December 21st, Richmond completed the first 3 conversions. The jumbos went to the 37th Tank Battalion, 4th Armoured Division. The battalion was staging for movement north. Something big was happening in the Ardennes. Details were scarce, but the urgency was clear. One of those converted jumbos was bumper number C6, Company C. The crew had nicknamed it Cobra King months ago, back when it carried a 75. Now, it mounted a 76mm M1 gun with 50 rounds of mixed ammunition, TM, 62 armor-piercing capped, M42 high explosive, and 3 rounds of something new, something special. M93 HVAP, high-velocity armor-piercing, tungsten carbide core, muzzle velocity 3,400 feet per second, capable of penetrating 200 millimeters of armor at 100 yards against perpendicular plate. The Army had shipped 2,000 rounds of M93 to Europe by air in August. Another 16,000 rounds had arrived by November. With thousands of 76mm guns in theatre, that meant most tanks carried 1 HVAP round per month, maybe 2 if they were lucky. Cobra King's crew got 3 rounds. They didn't know it yet, but those 3 rounds represented the cutting edge of American anti-tank ammunition technology. And in 5 days, they'd learn exactly what tungsten could do to German armor at combat range. December 22nd, 1944. Arlon, Belgium. The 4th Armoured Division's Combat Command B assembled in darkness at 0330 hours. Lieutenant Colonel Creighton Abrams stood beside his command half-track, watching the 37th Tank Battalion form up. 20 medium tanks operational. Down from the 46 the battalion should have had. The fighting from Normandy through France into Belgium had consumed machines faster than replacement could deliver them. Cobra King sat at the head of the column. First Lieutenant Charles Boggess commanded the tank now, his 4th Sherman since June. He'd survived 3 knockouts, walked away from 2 fires, and learned the hard way that surviving in a Sherman required equal parts skill, luck, and a willingness to close distance fast before the Germans could bring long-range guns to bear. The briefing had been clear. German offensive in the Ardennes, American units overrun. The 101st Airborne cut off in Bastogne. 3rd Army pivoting 90 degrees north to break through German lines and relieve the siege. The 4th Armoured Division was Spearpoint. 37th Tank Battalion was leading edge of Spearpoint. Boggess checked his crew. Gunner Corporal Milton Dickerman. Loader Private James Murphy. Driver Private Hubert Smith. Bow Gunner Private Harold Hafner. They'd been together since October. That was ancient history for tank crews in this war. "We're rolling in 5, Boggess said over the intercom. "Standard advance. We're taking point. Stay sharp." The column moved north at 0400. Temperature was 19 degrees Fahrenheit. Snow on the roads. Limited visibility. Perfect conditions for ambush. The Jumbos led because they could survive the initial contact. The lighter Shermans followed, ready to maneuver and flank once enemy positions revealed themselves. For 3 days, the 4th Armoured fought through German defensive lines. Every village was contested. Every crossroad turned into a killing ground. American casualties mounted. Tank losses accumulated. But the division kept pushing north toward Bastogne. On December 26th, Abrams ordered the 37th to make a direct thrust through the village of Assenois, 5 miles to Bastogne. German positions between here and there. No time for careful reconnaissance. No time for tactical finesse. Just speed, violence of action, and whatever armour could survive to reach the objective. Cobra King took point. Boggess knew what that meant. His tank would draw every German anti-tank weapon in Assenois. The Panzerfausts would come first, ambush range, no warning. Then the towed anti-tank guns if the Germans had time to bring them to bear. The Jumbo's armour would have to hold. The column entered Assenois at 1500 hours. Visibility dropped to 200 yards in the narrow streets. The first Panzerfaust hit Cobra King from a barn on the left at 80 yards. The hollow charge warhead detonated against the side armour. Inside, the concussion felt like a car crash. Boggess shook off the impact and kept moving. "Keep going! Don't stop!" Second Panzerfaust from the right. Another hit on the turret. No penetration. Cobra King's engine roared, pulling the 42-ton tank through the killing ground at 20 miles per hour. Behind them, the other Shermans poured fire into every building. The 53rd Armoured Infantry's half-tracks followed, infantry dismounting to clear structures room by room. Assenois burned. But Cobra King kept rolling north, away from the village, away from the Panzerfaust teams, toward whatever waited on the road to Bastogne. What waited was something the Americans hadn't expected, and something the Germans absolutely did not want to face. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. December 26th, 1944, 1650 hours. The woods, north of Assenois, looked empty. Boggess kept Cobra King moving at full speed. A felt 22 miles per hour felt glacial when every tree line could hide a panther. The road climbed toward Bastogne through heavy timber, perfect ambush terrain, perfect place to die if the Germans had positioned armour to block the approach. The gunner's periscope caught movement at 1,200 yards. Boggess grabbed his binoculars, 2 vehicles in the trees, low profile, sloped armor, Panthers. Exactly what American tank commanders had been taught to fear since Normandy. Gunner, 12 o'clock, 1,200 yards. Enemy armor. Dickerman traversed the turret, bringing the 76mm gun to bear. Through his sight, the Panthers looked hull down, taking advantage of a ridgeline that gave them perfect fields of fire. At 1,200 yards, the doctrine said American Shermans died before getting into effective range. The 75mm M3 couldn't penetrate Panther frontal armor beyond point-blank distances. Even the 76mm struggled with the Panther's glacis. But Cobra King wasn't carrying standard ammunition anymore. Murphy pulled an HVP round from the special storage rack, black-painted tip indicating tungsten core. 3,400 feet per second muzzle velocity. Capability numbers that belonged in technical manuals, not combat. Load HVAP. HVAP up. Boggess knew the mathematics. The Panther's frontal glacis was 80mm thick, sloped at 55 degrees from vertical. That created an effective thickness of about 140mm. Standard M62 armor-piercing ammunition could penetrate 109mm at 1,000 yards. Not enough. Not even close. The M93 HVAP could penetrate 150mm at 1,000 yards. In theory, on paper, according to ballistic tests conducted at Aberdeen Proving Ground, where perfect conditions and carefully controlled experiments produced numbers that might not survive contact with combat reality, Boggess gave the order anyway. Fire. The 76mm cracked. The tungsten penetrator crossed 1,200 yards in 1.8 seconds. The impact on the lead Panther's turret was visible through binoculars. A flash of light, a shower of sparks, and then smoke pouring from the commander's cupola. The turret stopped moving. The Panther sat motionless. Reload HVAP. HVAP up. The second Panther began traversing toward them. Cobra King was stationary, presenting a full frontal profile at 1,200 yards. But the Jumbo's frontal armor was effectively 6 inches thick. The Panther's 75mm K-42 could penetrate that at ranges below 500 yards. Maybe. The mathematical advantage belonged to Boggess's crew. Fire. Second impact. Second penetration. The Panther's engine compartment erupted in flames visible even at this distance. The crew bailed out, silhouettes against fire, running for the tree line. Cobra King had just killed 2 Panthers at 1,200 yards with frontal turret shots. Nobody told the crew that was impossible. Nobody explained that tungsten penetrators lost effectiveness against sloped armor. Nobody mentioned that combat conditions, stress, motion, imperfect range estimation, were supposed to degrade performance below laboratory standards. The crew just knew they'd survived an encounter that should have killed them, and that the 76mm gun with HVAP ammunition had done something American armor hadn't accomplished consistently since Normandy, AGA win, a long-range engagement against German heavy tanks. Boggess didn't stop to examine the kills. Cobra King kept rolling toward Bastogne. At 1650 hours, they spotted American helmets in the tree line ahead. The 326th Airborne Engineers, Bastogne perimeter. Lieutenant Boggess stuck his hand out as an engineer approached the tank. "Glad to see you," the engineer said. With those 4 words, the siege of Bastogne was broken. But what happened to Cobra King that afternoon mattered more than one tank reaching one objective. It mattered because ordnance officers at division headquarters were compiling after-action reports from the Ardennes. They were reading accounts of 76mm guns killing Panthers at ranges doctrine said were impossible. They were seeing data that contradicted 3 years of accepted wisdom about American tank gun performance, and they were starting to ask the question that would reshape American armor tactics for the rest of the war. What else had they been wrong about? January 5, 1945. 3rd Army Ordnance Depot, Luxembourg. Major Thomas Saunders compiled the ballistic performance data from the Ardennes fighting. 23 documented engagements where 76mm guns with HVAP ammunition had engaged Panthers at ranges exceeding 1,000 yards. 17 resulted in kills. 4 resulted in mobility kills. 2 failed to penetrate but caused the Panthers to withdraw. The mathematics didn't support those results. According to pre-war ballistic calculations, HVAP against highly sloped armor should have failed more often than it succeeded. The tungsten penetrators were supposed to ricochet at extreme angles. Combat data said otherwise. Saunders pulled the Aberdeen test reports. The original M93 HVAP testing had been conducted against perpendicular plate, 0 degrees obliquity. The Panther's glacis was 55 degrees from vertical. That difference should have mattered. It should have caused the penetrator to deflect rather than penetrate. What the test reports didn't account for was crew skill. American tank gunners in late 1944 weren't the same troops who'd landed in Normandy. 6 months of continuous combat had created experts in range estimation, target identification, and shot placement. They weren't aiming at glacis, plates. They were targeting turret fronts, gun mantlets, hull sides, any vulnerable point that presented itself. The Panther's turret front was 100mm thick with less slope than the hull. The gun mantlet varied from 100 to 120mm, depending on model variant. At 1,000 to 1,200 yards, HVAP could defeat both targets with reasonable probability. The combat data revealed something else. German tank commanders were changing behavior. Panthers that would have pressed attacks in July were withdrawing in January when faced with 76mm fire. The psychological impact of penetration at long range was causing tactical changes that couldn't be measured in armor thickness or muzzle velocity. Saunders wrote his report with careful language. The M93 HVAP ammunition demonstrates effective anti-armor capability against Panther-class targets at ranges exceeding 1,000 yards when employed by experienced crews, targeting vulnerable areas. Field performance exceeds laboratory predictions for sloped armor penetration. What he didn't write, what he knew but couldn't prove with data, was that American crews were starting to believe their weapons worked. And belief mattered in armored combat. Crews who thought they could win engaged more aggressively, took better shots, pressed attacks that doctrine said they should avoid. The Jumbo, with its 76mm gun, was creating that belief. Not because the armor made crews invincible. 2-3-30 kills, the suspension failures and mobility kills proved that. But because it let crews survive long enough to learn that their guns actually worked at distances everyone said were impossible. February 3rd, 1945. Patton's Third Army had completed upgunning operations on approximately 100 M4A3E2 jumbos. The conversion program used salvaged 76mm guns from knocked-out standard Shermans. Every weapon that could be recovered, inspected, and returned to service was mounted in a jumbo turret. The tanks went to spearhead units, battalions that led every advance, absorbed the first contact, and needed to survive what came next. Staff Sergeant William Pierce commanded one of the converted jumbos in the 10th Armoured Division. His crew had received the tank in late January with 17 rounds of HVAP. 17. The supply situation had improved since December, but 17 rounds per tank was still rationing. Use them on Panthers and Tigers, his platoon leader said. Nothing else. Standard ammunition works fine against Panzer IVs and lighter vehicles. Save the tungsten for targets that need it. Pierce's crew developed protocols. Standard M62 armor piercing for first contact against unidentified targets. HVAP in reserve for heavy armor. High explosive for infantry and soft targets. The loader had to know ammunition types by touch in combat conditions, reaching into storage racks in a lurching, buttoned-up tank where visibility was 0 and confusion was constant. February 24th, near Trier, Germany. Pierce's tank led a column through morning fog, visibility maybe 300 yards. The lead Sherman in front of them, a standard M4A3 with 76mm, exploded without warning. Smoke and fire, the crew bailed. Whoever hit them was invisible in the fog. Pierce stopped his jumbo, using it as mobile cover while the infantry dismounted. Through his periscope, he caught movement at 800 yards. Gun mantlet like a massive casting, Panther, hull down behind rubble. Gunner, target Panther, 800 yards. His gunner already had the 76 trained on target. I see it, loading HVAP. The fog was thinning. At 800 yards, the Panther's commander would see the jumbo soon if he hadn't already. Pierce knew the next few seconds would determine who shot first. In tank combat, first shot usually meant survival. Second shot usually meant burning. Fire when ready. The 76 fired. The tungsten penetrator struck the Panther's turret ring, the junction where the turret met the hull, the weakest point on German heavy tanks. The crew training paid off. The gunner had aimed for vulnerability, not for center mass. The penetrator went through the ring, into the turret basket, and created a pressure wave that incapacitated the crew. The Panther sat silent, disabled, not burning, not exploding, just stopped. That meant the crew might recover. Pierce fired 2 more rounds, standard M62 armor-piercing, into the hull to ensure the kill. Then his tank moved forward, covering the infantry advance. These engagements accumulated through February and March. After-action reports filled ordnance files. Tank commanders learned what worked. Gunners refined their targeting. Loaders developed muscle memory for ammunition selection. The 76mm gun stopped being inadequate for fighting German heavy tanks and became effective when properly employed by trained crews. The shift was subtle. No dramatic moment, no single battle that changed doctrine. Just cumulative experience proving that American weapons, used correctly, could compete with German armor. The HVAP ammunition made that possible, but crew skill made it consistent. March 9, 1945, Aberdeen Proving Ground, Maryland. Colonel William Davis supervised testing that should have been conducted in 1944. Comparative Ballistic Analysis, AAP, American 76mm HVAP versus captured German armor at combat ranges. A Panther sat on the range at 1,000 yards. Aberdeen had several Panthers now, captured in France and shipped back for evaluation. This one had seen combat, track damage, superficial armor scarring, the kind of wear that came from months in the field. The test protocol was simple. Fire M93 HVAP at progressively difficult target points from 1,000 yards. Record. Penetration. Deflection. Partial penetration. Build empirical data about what worked and what didn't. First shot. Turret front. Aiming point centered on the gun mantlet. Penetration. The tungsten core punched through 110 millimeters of armor and exited through the turret rear. The penetrator was traveling fast enough at 1,000 yards to defeat quality German armor even at less than ideal impact angles. Second shot. Turret side at 30 degrees obliquity. Penetration. The sloped impact caused some deflection, but the velocity and hardness of the tungsten core overcame the angular disadvantage. Third shot. Glacis plate at 55 degrees obliquity. Deflection. The penetrator ricocheted at approximately 30 degrees from point of impact. This matched combat reports. Frontal glacis shots at long range failed consistently, but nobody aimed at glacis plates if they had other options. Davis compiled the results. The M93 HVAP demonstrates reliable penetration capability against Panther-class armor at 1,000 yards when targeting turret and hull-side aspects. Glacis penetration remains unreliable at ranges exceeding 800 yards. He added a notation that didn't belong in technical reports but mattered more than ballistic coefficients. Combat effectiveness appears to correlate more strongly with crew training and target selection than with theoretical penetration maxima. Experienced crews consistently achieve kills that laboratory testing suggests should be statistically improbable. What Davis was documenting was something the Germans had known since Normandy. American tank crews didn't quit. They didn't break contact when facing superior armor. They closed distance, maneuvered for flanking shots, and pressed attacks that German doctrine said would fail. The HVAP ammunition gave them tools that made that aggressiveness lethal at longer ranges. The Jumbo had been designed as an infantry support vehicle. It became a tank, destroyer by accident. The 76mm gun had been considered inadequate against Panthers. It became effective through crew skill and ammunition development. None of this followed the plan. All of it worked. April 23, 1945. Forward Maintenance Depot near Regensburg, Germany. Captain Harold Richmond, ZOME, the same officer who'd converted the first Jumbos back in December, supervised repairs on 3 M4 A3E2S that had fought from Bastogne to Bavaria. The tanks showed hard use. Suspension springs replaced multiple times. Transmissions rebuilt. Armour pitted from anti-tank weapon impacts that hadn't penetrated but left surface damage. One tank had taken 43 separate hits, Panzerfausts, 88mm rounds, 75mm anti-tank gunfire. The glacis showed impact craters. The turret was scarred. But the crew had survived every engagement and the tank was operational. That was the Jumbo's victory, not being invincible, but being survivable. Richmond walked through the maintenance bay, examining the damage patterns. Almost every hit had struck frontal aspects. Almost none had penetrated the main armour. The few penetrations came from lucky shots through vision ports or the driver's hatch. The armour itself had worked exactly as designed. "These things are indestructible," said one of his mechanics, a corporal who'd been rebuilding Shermans since North Africa. "Nothing's indestructible," Richmond said, "but these are close enough." The real revelation was what the Jumbos proved about tank design philosophy. The Germans had built sophisticated vehicles, Tanthers with excellent guns and sloped armour, Tigers with massive firepower. But German tanks broke down constantly. The complicated engineering that made them superior on paper made them fragile in practice. The Jumbo was simple. Take a reliable platform, add more armour, upgrade the gun, keep everything else standard, so repairs used common parts and trained mechanics could work on them. It wasn't elegant, it probably offended engineering purists, but it kept tanks in the fight. April 30th, 1945, the war in Europe had 6 days remaining. Colonel Creighton Abrams, TAA, who'd commanded the 37th Tank Battalion during the Bastogne Relief, TAC, compiled his final after-action assessment. The document covered the period from December 1944 through April 45, 4 months of continuous combat. His observations mattered because Abrams had commanded the unit that first used upgunned Jumbos in combat, and his experience carried weight. The M4A3E2 Jumbo Sherman, when armed with the 76mm M1 gun and equipped with M93 HVAP ammunition, demonstrates effective anti-armour capability against all German tank classes, including Panther and Tiger. Armour protection enables crews to survive initial contact and manoeuvre for optimal firing positions. Vehicle reliability remains acceptable, despite weight-induced stress on suspension components. He added a personal note. American crews no longer view German heavy armour as an invincible opponent. This psychological shift correlates directly with the fielding of Jumbos and HVAP ammunition. Crews who believe their weapons work fight more effectively than crews who fear enemy superiority. That last observation captured something that didn't fit in technical specifications. The Jumbo hadn't just provided better armour, it had provided confidence, and confident crews took better shots, made smarter tactical decisions, and survived combat that would have killed them in lesser vehicles. The final statistics told their own story. Of the 254 M4A3E2 Jumbos produced, approximately 170 remained operational by war's end in Europe. 84 were combat losses, knocked out by mines, destroyed by concentrated fire, disabled by mechanical failure and captured. But that meant 67% survived 5 to 8 months of continuous combat operations. Standard Sherman loss rates were running about 200% over the same period, ECA, meaning replacement tanks had been destroyed and replaced again. The Jumbo's armor had saved hundreds of American lives by letting crews survive encounters that would have killed them in standard vehicles. And the 76mm gun with HVAP ammunition had proven that American weapons could compete with German armor when crews understood how to use them. The penetration at 1,200 yards wasn't theoretical anymore. It was documented in after-action reports from 3 armored divisions operating across Western Europe. May 8, 1945. VE Day. The war in Europe ended at 23:01 hours Central European Time. American armor had advanced from Normandy to Czechoslovakia. They'd fought through hedgerows, destroyed cities, winter forests, and open plains. They'd faced everything the German army could deploy: Panthers, Tigers, King Tigers, self-propelled guns, and the most sophisticated anti-tank defenses ever constructed. The Jumbo Sherman wasn't the reason they won. Industrial capacity was the reason. Air superiority was the reason. Logistics and replacement capacity were the reason. But the Jumbo mattered because it proved American engineering could adapt faster than German production could respond. The Germans built sophisticated weapons that required specialized maintenance and precision manufacturing. When those supply chains collapsed, their armor became immobile. The Americans built simple weapons that could be repaired in field conditions using common parts. When combat damaged them, mechanics had them operational again within days. The Jumbo took that philosophy to its logical conclusion. Take proven technology, make it more survivable, give crews weapons that let them fight back, then produce enough of them that losses don't matter because replacements are already in the pipeline. The 76mm gun solved the firepower problem. The HVAP ammunition solved the range problem. The Jumbo armor solved the survival problem. None of it was elegant. All of it worked. June 1945. The War Department published a classified technical bulletin analyzing M4 A3E2 combat performance. The conclusions would influence American tank design for the next 3 decades. The M4A3E2 demonstrates that adequate armor protection enables crew survival and weapon effectiveness under conditions where lighter vehicles fail. Future tank development should prioritize frontal armor thickness sufficient to defeat contemporary anti-tank weapons at combat ranges. They'd learned the lesson the Germans knew since T-34 encounters in 1941. Armor mattered. Crews in well-protected vehicles fought more effectively because they weren't preoccupied with survival. The American armor community had spent 3 years believing that mobility and numbers could substitute for protection. Combat proved otherwise. The HVAP ammunition received its own analysis. Tungsten core penetrators demonstrate superior performance against homogeneous armor when employed at velocities exceeding 3,000 feet per second. Development of improved penetrator designs should continue in parallel with gun development programs. That was bureaucratic language for tungsten works. Make more of it. The supply limitations in 1944 had constrained what American guns could do. If HVAP had been available in quantity from Normandy onward, the kill ratios against German armor would have been dramatically different. The Jumbo's legacy wasn't just the 254 tanks that fought in Europe. It was the proof that American industrial capacity could adapt doctrine faster than enemies could counter it. When Shermans proved vulnerable, they added armor. When the 75mm proved inadequate, they installed 76s. When standard ammunition couldn't penetrate, they developed HVAP. Each adaptation took months, not years. From problem identification to fielded solution in timelines that the German military-industrial complex couldn't match. That speed of adaptation was the actual advantage. Not individual tank quality, not superior gun performance, just the ability to recognize problems and fix them before losses became catastrophic. The Germans called it the Jumbo trick for a reason. They didn't understand how Americans could field up-armored Shermans so quickly. German tank development cycles ran 2 to 3 years from concept to production. The Americans went from prototype to combat employment in 6 months. It violated everything the Germans understood about weapons procurement. What they missed was that the Jumbo wasn't a new tank. It was a Sherman with more armor. All the complicated development work, automotive system, suspension, gun mount, turret design, TAT, had been completed years earlier. Adding armor was just welding steel to proven components. That kind of incremental improvement could happen at industrial scale while maintaining production rates. The Germans designed masterpieces. The Americans designed something good enough, then improved it in the field. The masterpieces lost. The M4A3E2 Jumbo served in American armored units through the Korean War. Some remained in service with other armies into the 1970s. The basic Sherman design proved so adaptable that variants continued operating decades after World War II ended. The Jumbo was the ultimate expression of that adaptability, proof that evolutionary improvement could compete with revolutionary design. The 76mm gun went on to arm American tanks through Korea. When 76 equipped Shermans faced Soviet-made T-34, 85 seconds in Korean combat, they won consistently. Better crew training, better optics, and HVAP ammunition that was finally available in adequate quantities. The gun that had been criticized as inadequate in 1944 became the standard by which American tank weapons were measured for the next decade. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.